I do not know linear algebra, like not even a little bit. And I currently work at Night Lab at Northwestern University, where we build experimental tools for the future of media. I started off there as a developer, and I recently moved into a new role where I manage our foray into things like voice UI and virtual reality. Alright, and so that's me, and I hope you don't mind, but I'm actually going to make a couple assumptions about you, just based on your presence in this room. I'm going to assume that, one, you are a person who is alive in 2017. I think that I am pretty safe on that one. And I am going to assume that you kind of like computers. And if you don't kind of like computers, I apologize. Not just because I made that false assumption about you, but because you are also clearly on what I can only assume is a really weird date. And I'm going to make a third assumption based off of those previous assumptions I made, and that is this. As a person living in 2017 who kind of likes computers, I'm going to assume that you've heard quite a bit this year about virtual reality. But I'm not going to assume that you necessarily like it. If you feel exhausted by the new information and products that are constantly coming out and how they kind of seem to overwrite each other and they're all really expensive, but if you buy one, then like something even cooler is going to come out in like 6 months. That is totally fair. I get that. If you're intrigued by VR as a concept, but it doesn't seem super accessible, and you're not super impressed by the content because none of it really seems like it was made by or for someone like you, so maybe you'll just kind of keep an eye on it and see how everything eventually shakes out. I get that too. But when curious outsiders decide to see how things shake out with a new technology, the future gets decided by those who had the privilege to get to the space in the first place. And we've played that out before with like a lot of new tech, and it's super boring. So if you don't think VR is for you, I think your voice is even more important in VR. And that's why I'm particularly excited to talk about this here at Women Tech Makers. There are incredible women in VR. Over on the left, that is Jessica Brilhart, who is the principal filmmaker for VR for Google. She was a film editor before she got into VR, and she's done a lot of really important writing about the technical aspects of storytelling. I'll show you some diagrams she's worked on later in the talk. In the middle, we have Stephanie Hurlbert. She's a graphics programmer who used to work at Unity and Oculus and started her own company that works on compression. She also does really important work getting folks from marginalized groups who are interested in graphics and low-level programming in touch with mentors. And then over on the right, we have Nani de la Peña, who is sometimes called the godmother of VR. Does anybody know what the first piece of content for the first version of the Oculus Rift was? So it was this piece called Hunger in LA, which was by Nani de la Peña. And it was built to convey her experience as a journalist covering the Los Angeles Food Bank and watching a man collapse in a diabetic seizure while waiting in line for food. Palmer Luckey was her intern. He built, so like the history of VR is not one of first-person shooter games. The history of VR has room for all kinds of story and all kinds of people. There are so many incredible women to look up to in VR, like a lot of people that you do not see on that slide. But where I wish I saw more women is in WebVR Slacks, on a Stack Overflow, and like in the open source discussion list. My name is Rebecca, which is a pretty common name. At my last job, there was a time when 50% of the women engineers were named Rebecca. So I've started doing this thing. Whenever I join a new VR community, I try to get my first name as a username. And if it's available, I get super bummed out because there's like 5 Steves. So I hope that after today, I'll see more of you around those spaces. All right, so who's heard of this idea of Metaverse? Anybody? Oh, cool, awesome, great. So that's a term coined in Neil Stephenson's Snow Crash. I have not read that book. But it's a word that comes up a lot in VR, and especially in WebVR communities. And what it is this idea that we will one day be living in virtual connected spaces that are physically persistent. And if that comes to pass, like if we're actually living inside of our computer, it's incredibly important that these spaces are built by all kinds of people and for all kinds of people. VR expands the way we interact with our computing environments. It has the potential to be more ergonomic than flat computing. Flat UI conventions are obsolete in VR and have to be reinvented for immersive spaces. The AAA games that come out in 2017 don't matter all that much. The tech is changing too fast. What looks awesome today will look really boring in 6 months. I've been doing VR dev for probably not quite 2 years at this point. And already I've been through like at least 2 breaking points where I'm like, everything that I used to know is completely wrong now. And this is why WebVR is important, because it makes VR development and distribution accessible to anyone with a browser. Because I build tools for journalists, but you might build tools for lawyers or teachers or grocery store managers. Because VR in the browser is here, and if you have basic web development skills, there's no reason that you can't be building experiences for those audiences in VR now. What's going to last out of VR dev in 2017 is the way that we define these patterns of interaction, which is why it matters that the people working on this content come from different backgrounds. This tech shouldn't just mature around one kind of people. Alright, so what is WebVR? WebVR is a JavaScript API that allows us to build virtual reality experiences for the browser. When you see WebVR written like that, one word, we're talking about the API. Different protocols are going to emerge really rapidly, and you'll see WebVR with a space, and that's going to just be like more generally and conceptual VR, browser-based VR. But what does that really mean? All right, so what that means for us as developers is that when a user is viewing our experience using a virtual reality-enabled device, which might be an HTC Vive, it might be an Oculus Rift, it might be any smartphone that is better than an iPhone 5. We can pull the API to see what kind of device they're using and what capabilities that device has. It tells us what we call the pose, and that's the position, the orientation, velocity, and acceleration. It tells us what the user's field of view, or the portion of the experience that is visible to the user at a given time is. And finally, it offers us an immersive display mode that we can present to the user so they can view our experience in VR. What does it actually mean to be in VR mode? Well, first of all, it splits your screen so that your left eye sees an image that is slightly offset from the one that your right eye sees. This allows your mind to create the illusion of a 3D image. It applies mesh-based barrel distortion, which compensates for the way that the lenses you use to expand your field of view distort what you're seeing. This is why, like, if you look at something, I like to use this demo for talking about barrel distortion because it's got these nice lines in it. And if you look at something that's linear in stereoscopic mode, but not through lenses, it kind of looks like it's sagging a little bit. Barrel distortion is really, really interesting. I have some really good, like, terrifyingly nerdy blog posts that I can send you about that. And it also applies chromatic aberration correction. Sometimes when you look through lenses, you'll notice color grain towards the edges, and VR mode corrects for that. And this is all available right in your browser, or at least some of your browsers. WebVR.rocks is a handy website that you can use to track browser and device compatibility. But there is a polyfill. So we can implement it as a library, which means we don't have to worry about downloading an experimental browser or anything. All right. So now we know what WebVR is, and we're going to talk about why WebVR is so special. And one is that idea of accessibility. Like, you don't have to invest in a new skill set in order to start making virtual reality content today, which is great because the adoption is like relatively low at this point. And so, like, I don't want you to like have to learn something crazy and complicated and like make a giant risk in your career in order to just like start playing around and experimenting with VR. Open standards and open source make it easier for new and smaller companies to bring their products to market. And also, like, I can share my WebVR stuff with my mom and dad who, like, don't have access to, like, a ton of crazy VR headsets and stuff. And that's really great that they can see what I'm working on, like, on my phone. It's a good selling point if you're trying to get people excited about that. Alright, so where is all of this going? WebVR isn't necessarily the sexiest part of VR to be working in right now. The performance is a little iffy, and we are not pumping out those AAA games, but it's really integral to the medium's future and survival. That is what the VR ecosystem looks right now. If you're going to build an app, you're probably going to use an engine that has a specific build process for targeting each of these 4 major operating systems. And then each of these operating systems only ships to a small number of these devices. This means that if I want my app to be viewable on a range of VR devices, I have to build my app several times. It means that if you decide to start a VR headset company tomorrow, you could have a really awesome headset, but you're going to have a really hard time convincing me to build content for that headset because your headset probably isn't in many people's homes yet, and I'm going to have to spend a lot of expensive developer time making my app specifically for your headset. And this is the lovely linear organized future. The Kronos Group, which is a nonprofit consortium that creates free and open standards for a variety of domains related to, like, mostly interactive media, like if you've heard of, like, Vulkan or WebGL, has undertaken the OpenXR project. The purpose of OpenXR is to define 2 standard layers in order to eliminate that sense of risk and fragmentation. The first, an application interface, so that an app produced by any engine interacts with the operating system in the same way. And the second is a device layer for providing standardized interactions between operating systems and devices. And this is kind of the most exciting foundational work, even though it, like, looks like a boring UML diagram. And, like, the WebVR spec and the WebVR community has been and continues to be a huge part of shaping this. Alright, so what I like about working in VR right now is that hardware is tied so closely to software, is tied so closely to design and UX. So I want to talk a little bit about what we know right now about making VR experiences that are quality and useful. When we think about what constitutes good VR content, I like this graphic by Bo Cronin that looks at Maslow's hierarchy of needs for inspiration. So the basis of this pyramid is comfort. You owe it to your user not to make her barf. Once we've fulfilled the minimum requirement of comfort, we begin to work on interpretability. Can your senses understand how to inhabit this space? When we combine comfort and interpretability, we have presence. And I think that if you're interested in working in VR right now, like, what you should really be interested in working on as a new storytelling asset is presence. The ability to put a person in the space that you're telling them about. Alright, after interpretability, we earn the right to work on usefulness. Does the experience deliver on its basic value proposition? Right now, my work in the lab, and honestly, like, most VR work in industry, is most useful when it's focused on these 2 levels. We can investigate design patterns that are interpretable and string them together in a way that conveys information. Cronin puts delight at the top of his pyramid, which is less than my favorite word. But I agree with the basic premise that only once we've fulfilled VR's basic usefulness can we focus on artistry. Alright, so it's probably useful for us to spend a little more time on the comfort level of the pyramid before moving on. Here's a quick list of how to prevent your users from getting motion sickness. You want to keep that frame rate up. For developers, what that means is minimizing WebGL draw calls. Our target frame rate is around 60 frames per second. We want to keep our latency below 20 milliseconds. We want to avoid sharp and unexpected camera rotations. I was at a big game developer convention out in San Francisco a couple weeks ago, and I was trying out a demo of a VR roller coaster that was, like, kind of, they had it set up like, I don't know, did you guys ever going to Chuck E. Cheese at all? Or like it's like one of those like goofy little kids rides. So you're in a headset and there's this platform that's moving around. And it was the most boring roller coaster in the world because you would get sick if it wasn't. It was really fun. But you want to give all fixed objects a fixed point of reference. If anybody grew up taking ballet, it's like when you're learning how to spin and learn to focus on one point in the room. You don't want to play around with blurring or depth of field effects because we actually don't have the tools that support them in VR, even though they're really common cinematic effects, because we don't have a frame, so it makes no sense to play around with depth of field because you don't know what your user's looking at, which is something that pretty much everyone learns the hard way when they make VR content. User testing in VR is really interesting right now because so often you're dealing with a user who is like, they're user testing your thing, and it's the first time they've ever been in a headset, and so their feedback is going to be more about what that experience is like, and it's really hard to understand like what you can actually take from that, or else you are user testing on other people who make VR content, who are, useless in an entirely different way. We also want to avoid sudden lighting transitions. Strobe lights are annoying, like in regular life. Being trapped inside a headset full of strobe lights is really, really annoying. And this is my favorite puke gif. Alright, so now that we've met the bare minimum of not making people nauseous, we can talk about the fun stuff. So much of when you're planning VR interfaces is teaching your user to discover information in new places. This is why when you do a lot of VR demos, you notice the menu is pretty often like on the ground, like just a little bit in front of you, like right where, kind of where you'd expect your shoes to be. As a designer and developer, you want to leverage the natural instincts that people have when they enter a 360 environment and give them feedback right away that that's going to be rewarded. This is a diagram by Jessica Brillhart, who I mentioned earlier. I think about this like almost every day. I make my students look at it all the time. It really annoys them. So prototyping immersive interaction in 2D space is really difficult, maybe even futile. I like prototyping with Legos a lot right now. But this little onion diagram is a really useful organizing structure. The idea is that you think of your interaction space as a series of concentric circles, and you plant points of interest to help your user move from the center of the circle to the outside. These points of interest can be indicated by color contrast, or difference in form. They can be motion-based, having something zoom out from behind people because you know their pose, so you know like where they are. So just having something come from behind them is a really good way to shift their direction. Also sound and light. And I'm really excited to see how we develop methods for gracefully degrading these experiences across devices and how that ends up changing what we expect to get out of those devices. And that is where it starts to be really handy to have a framework. Right. So A-Frame is an open source project maintained by Mozilla. It wraps 3JS, so if you've worked with 3JS before, it exposes all of that functionality. Something that the A-Frame folks like to say is that 3JS is kind of like the jQuery of creating graphics in the browser, and A-Frame is similar to bringing like an MVC style architecture to it. If you have never even heard of 3JS, that is totally fine too. I hadn't worked with 3JS when I started working with A-Frame. I had done a little bit of browser-based VR, but it always seemed like it took too much boilerplate to get it started. So I was building most of my stuff in a game engine. And what's so smart about A-Frame is that, first of all, it reduces all of that boilerplate to one HTML tag. It's just A-C. But also that it uses the entity component system style of architecture that you see in game engines and brings that to the DOM. So we'll spend some time a little bit later talking about exactly what that means and how it works. The third thing, and quite honestly, maybe the most important selling point of the framework, is the inspector. So anytime you are in an A-frame scene, you can just hit Control-Alt-I, and here you'll see something else that will feel familiar to both web developers and game devs for different reasons. Just to give you a brief idea of what you're looking at here, this is an interactive 360 photo experience that some of my students worked on this fall. The way this project works is that there is a 360 photo that is projected onto a sphere but rendered on the inside, because that's how 360 photo works in first-person VR. It's kind of like the Truman Show when he goes to the border. Spoiler alert for the Truman Show. Alright, so on the right we see a pane that looks pretty similar to the inspector from the Unity game engine. And so those fields allow you to set the position, scale, rotation, and other attributes of the object selected. You can also use the arrows inside of the sphere and adjust those attributes, which is just really, really great. And on the left side you have the scene graph. And this, if you come from a web background, will make you feel right at home because it is very similar to the Elements tab of your developer tools. And you can use it in a similar way. The scene graph provides a concise 2D representation of your scene. You can use it to add or delete entities, which are displayed by their HTML tag or ID. The structure of your scene graph looks like the structure of your code. Alright, so to show you how this works, I'm going to walk you through how I made a very basic A-frame scene. That one. It is a box. It spins in VR. It is mostly HTML with just a tiny bit of JavaScript. So how we'd start this off is pretty much how we'd start any random web page. We open up an HTML tag, close it down at the bottom. There's a head, a body. Just we call out to the A-frame library. And then inside of the body, we're going to set up an A-scene tag, so that encapsulates all of the annoying WebVR bootstrap. Anything we put between there is going to pop into stereoscopic view when we look at it on our phones in VR mode. This might seem super duper obvious, but you can build a whole website around the A-scene. It doesn't change the nature of your page in any way. It's just what's between those two tags that's going to show up in VR. Alright, so if you inspected what I just shown you, the very, very basic part, it would look like this. And you would notice that you already have a couple of entities into your scene. This is because A-scene also gives us a camera and two lights. If it didn't, we couldn't see anything. Alright, so you've heard me mention a couple times now, and you're probably hoping that I'm going to explain this entity component system. A-frame syntax looks like simple HTML, but it's actually this declarative way of invoking this pattern. The one-sentence explanation of ECS is that entities are objects, which are given behavior and appearance by components, and managed by systems. Alright, so if you put a plain entity into your scene, it's pretty boring. An entity doesn't really do anything until you attach components to it. It's just an object that has a specific position in space, rotation, and it has a rotation component and scale. You can think of it as being pretty analogous to an empty div. Alright, so this is the source code for the HTML in our project, and most of the things you see here are entities. If you look at this A-asset tags, and I should have given you an image with my numbers, but I didn't, sorry about that. That's a really good example of an entity that doesn't have any components applied to it, that we're just using to kind of A-frame loads from the inside out. Load order is really important in VR because lag causes nausea. So by putting in the A-assets tag and nesting the image one layer in, we know that it's going to be loaded and ready to go when our box is rendered. So there's not going to be any mismatch in timing in there. So it's that's a really good example of just using a plain entity kind of like an empty div. Alright. A-frame also ships with a bunch of primitives. Primitives are special entities with components attached to them that the A-frame teams decided are so useful and important that they should go right in the library. So there's a lot of primitives in that. I definitely took advantage of leveraging primitives when I built that scene. We're going to take a quick look at the sky primitive. This is the source code of the sky primitive, so, which you access just by calling a-sky. But what we can see here is there's this method called register primitive that does exactly what you'd expect it to do. And what's happening here is he's passing the name that he wants his primitive to have, and then registering a schema of components and their values for the primitive to have by default. So in this case, we can see that the sky, which is the background of your whole scene, is actually implemented as a sphere. It's really cool in the inspector. So it's a sphere, and the radius is 5,000. A-frame units are meters, so that's pretty huge. If you zoom out really far when you're in inspector mode, you can actually see the border of your sky, and it looks kind of like a box. Alright, and we can see that the default material the sky uses the color component with a value of white, and the shader component set to flat. However, as you'll see before, I overrode the color component. So to summarize what a component is, it does a lot of the stuff that CSS does. It's a modular chunk of data that can be applied to different elements in our scene, and it generally describes behavior, functionality, or appearance. So if you look at this, a lot of times when you show people who come from a web background A-frame for the first time, they freak out because they think it has a ton of inline CSS in it. But that's actually not inline CSS. These are actually values. Alright, and you can write your own components. And just for the sake of demonstration, I made a teeny tiny one here to change the color of the sky. All this does is grab a color out of an array and change it every 2 seconds. You see that I passed the name. It's very similar to the register primitive that we looked at earlier. I passed it the name I wanted to use to access it, change colors. I gave it one dependency because I want to make sure that that material is loaded before my component gets called, because it's going to target the material. All components contain a reference to the entity that they're applied to inside of this.el. So since I stuck this on the sky in mine, that contains a reference to the sky, but I could also stick it on the box. But in this particular case, I would not want to apply this component to 2 entities, because then we'd have weird flashing colors and we would probably make sense. And then you can see I just accessed our component declaratively from HTML. So that's right here with the change colors. And it is super simple. Okay. And so that is what it looks like. It's mostly composed of primitives, and then we're passing one component on the sky. Alright, so A-frame is in the process of building a registry, and they are actively seeking contributions. So if you find an interesting problem to work on, it's a pretty cool opportunity for a first open source contribution, because it can be something as simple as that change colors component. It's an interesting problem from like a product perspective, because it's like, what's something that I wish I had in the real world that could be useful to people? And you can implement that in like very few lines of JavaScript, and people will actually use it. They're not super great about saying exactly what they're looking for right now. They're kind of like, look at 3JS and see what hasn't been abstracted into A-frame, but it's definitely a place to start. And there are a ton of components that we haven't explored that ship right with the library, and the registry is getting more stuff added to it every day. It's also, at the end of the day, just JavaScript. It's endlessly extensible. I think it's a really great playground for folks who are in that stage. I don't know. Nobody's looking for like a first front-end job right now, right? All right, cool. But like a lot of my students will talk about going out on interviews, and they feel like every job interview they go on is asking for them to know a different framework. You can, with A-frame, like you can make a super simple like compartmentalized project with like Ember and React and Vue, and just like prove that you know how to learn something quick and can demonstrate it in a cool way. And I think that's really interesting. You can use Mustache or whatever kind of templating libraries you like. You can use D3. Alright, so that is, and the docs are not even terrible. Yeah, so that's a quick intro to building VR for the web with A-Frame. A-Frame's currently at version 0.5, which I started using A-Frame in October, and there's been 3 like fairly significant bumps, so that's fun. Version 5 is exciting. But yeah, I would describe the docs as not horrible and maybe even beginner friendly. Part of that is because so much of the heavy lifting is done in HTML, and it's declarative by nature. So like the circle primitive has 18 components that you can, so like that's a lot of things you can do with a circle. You can play around a lot in HTML before you get bored. I really like using it in an educational setting because there's a big part of learning front-end dev today where it's just like, it can get super discouraging because it's a long time before you make anything that looks like the websites that you use every day. And there are so many tools that just getting started can be pretty daunting. And you can use all of those things with A-Frame, but you don't have to. You can just use HTML and JavaScript, and just by putting your thoughts and new perspectives out there, you can contribute to the way that we design and develop for new tech. And that's cool and powerful. And yeah, the performance can be less than ideal. I don't have to tell you that. You know you're at a JavaScript talk. But it's the browser, so if you want to put out a fancy AAA game, you should probably not build it in A-Frame. You should put it in an app store and make yourself some money. But the AAA games aren't what's going to last out of this particular moment in VR. The tech is moving too fast, and each group of new games that comes out makes the previous one look really silly. What's going to last is the patterns and precedents we set for interacting with 3D space, and you can start working on that with the skills you have now.